Welcome to this presentation about modular power plants, our predictable power solution for flexible, efficient and reliable power generation. When customers require on-site power, a big standalone generator isn't always the most efficient or reliable solution. For example, is your customer looking for a large generator between 1 and 3 megawatts? And will his application load vary? And does he need prime power for long-term projects in remote sites? Or is he planning permanent or temporary installations that could be moved or upgraded or downgraded? Is his power supply critical and urgent? Then you might want to offer a modular power plant instead. A modular power plant consists of multiple smaller generators that run in parallel. And in many cases, it's a much more efficient, predictable power solution than a standalone generator that's sized for the full load. Compared to standalone generators, modular power plants are practically a plug-and-play solution. They are light, ready to be delivered off the shelf and easily installed. Modular power plants are also much more reliable. If one unit stops for maintenance or repair, the other generators can take over the load. With standalone generators, power is a case of all or nothing. Modular power plants are also more flexible and versatile. As power needs evolve, their units can be moved in and out easily. This vastly improves fleet utilization. It's no surprise that the resale value of these units is high. Even in terms of price, a modular power plant is a no-brainer. Normally in this range, 4 smaller units are cheaper than a single unit of the same nominal power. But that's not all. In applications with frequent low loads, modular power plants run more efficiently in terms of fuel consumption. And their engine's lifetime is extended thanks to better load levels and less running hours. Let's look at 2 examples from the field. In this first example, our customer needed a prime power solution for his industrial application. No mains were available, so he needed power 24/7. The maximum power need was estimated at 800 kilowatts. Let's first examine the load diagram. The power need is high from 6 in the morning until around 7 in the evening, with load peaks at around 10 in the morning and 5 in the afternoon. At night, the load is low. Typically, a site like this would be powered by a single 1 MVA unit, which would run at its full capacity 24/7. A terrible waste of power that could end up damaging the generator. When large, powerful generators are forced to run at low loads, their diesel engines will wear out much faster and fail. The solution? A modular power plant. When the load is low, only one machine needs to run. When demand rises to a normal level, the second generator will run, and during peak moments, the third can kick in. The system will also automatically rotate the units so that each unit performs roughly the same running hours. Units with higher running hours are stopped until the other units have caught up. Modular power plants also offer redundancy. If one generator stops, in this example, there are 2 generators to fall back on. If the standalone generator stops, the entire site is dead. This graph shows the specific fuel consumption of a standalone generator. This is the quantity of fuel it requires to produce 1 kilowatt in 1 hour. Just like any other generator, it is more efficient at a high load than at a low load. At a load of 200 kilowatts, a standalone 1 megawatt generator consumes 65 liters per hour. Let's now look at the specific fuel consumption of a modular power plant. At a load of 200 kilowatts, a modular power plant would only have a single unit running, and this unit would only consume 50 liters of fuel per hour. The gap between these 2 curves shows us how much money your customer can save. And the lower the load of your customer's application, the higher the potential for savings. By comparing the daily fuel consumption, we can complete the picture. In this case, had the customer gone for a modular power plant, he could have saved up to 30,000 euros in fuel costs every year and 85 tons of CO2. Let's look at a second example. A rental job that supposedly required a single QAC 1000. All we knew was that the job required 8 hours of power per day. We didn't know the application type, so we use remote monitoring to determine the load distribution. As the load diagram reveals, the load never exceeded 250 kilowatts, which made the standalone generator wildly inefficient. Once again, a modular power plant is a more efficient option. It adapts its power generation to the required load and offers redundancy. This way, fuel consumption can be vastly reduced, leading to significant savings in terms of fuel cost and CO2 emissions. To summarize, for the right kind of job, a modular power plant offers huge savings as well as a wealth of other advantages. So make sure you understand your customer's application, know his load profile, and make the most efficient offer. Modular power plants, a perfect example of predictable power.